Scientific notation was very common at RCT last year, so I want to make sure that you understand the process. And scientific notation is used mostly in science, and it's thinking about maybe atoms, particles that are really, really, really small in size, and where you might have many different pieces. The idea is that a standard calculator can only hold 8 digits, and often you are going to have numbers longer than 8 digits. So this is helpful when you're trying to use a calculator because you can type your number into the calculator in scientific notation. Scientific notation is a formula, basically. The first number has to be between 1 and 10. And then it's always multiplied by a power of 10. And then this number up here, which is the exponent, that is how many places to move the decimal. So that's the number of places that you move the decimal. It is not the number of zeros. So it's how many places you're going to move the decimal. And if you have it in this setup, this is scientific notation. And some of the questions are just going to ask you to transfer a number from scientific notation to standard form, which is how we typically write our numbers, or maybe from form into scientific notation. So we're going to do just a few examples. Let's say we had 3.72 times 10 to the 5th. If we want to write this in standard form, that's scientific notation, this number is between 1 and 10. That tells me how many places to move the decimal. The way I remember it is if my exponent is positive, I need to make this decimal move to the end of the number. If the exponent's positive, the decimal's at the end. So I need to take this decimal and move it 5 places to the right. So if I have 372, I'm going to go 1, 2, 3, 4, 5, and now my decimal's at the end, and the fillers are always zeroed. So this answer right here would be 372,000. Here's an example if the exponent is negative. Let's say we had 2.18 times 10 to the negative third. When the exponent's negative, I remember that a negative exponent means really small, which means the decimal needs to be at the beginning. So if the exponent is negative, the decimal's at the beginning. So if I take this number, 2.18, and I move the decimal 3 times to be at the beginning of a number, then my answer is going to end up being 00218. Most often, we don't round these numbers. We wouldn't change this, wouldn't change this. We leave digits as they are. Numbers that we can ignore are the ones that are zeros if we don't need them. In this case, we need all those zeros, and we need these zeros, but we're not going to round any of those other numbers. To go the other direction, if you started with a number in standard form and wanted to write it in scientific notation, it's the same idea, just backwards. So let's say we had 419,000,000. So that's 419 million. So we want to write this in standard notation, in scientific notation. So the first thing we have to do is write this number as a number between 1 and 10. In order for this number to be between 1 and 10, the decimal needs to go right there. So now the number is going to be 4.19. And I don't need these extra zeros, so those are the ones I can leave off. Now I need to say how many times did I move the decimal. Well, when the decimal started, it was here. So I had to go 1, 2, 3, 4, 5, 6, 7, 8. So I had to move 8 places. Now, the decimal is at the end of the number, so that means my exponent is positive. To go the other way, let's say we had 0,000,342. So the first thing we have to do is make this number into a number between 1 and 10. So that means I need to put the decimal after the first number that's not a 0. So our decimal needs to go right there. Now I need to identify how many times to move the decimal. So I needed to move it 1, 2, 3, 4 times. And when I look at the number in standard form, the decimal's at the beginning of the number, so my exponent is negative. And that is scientific notation.